Hello, it's me. Are you there? I ask myself that a lot, actually. Anyway, so I don't know what to exactly call this video that I'm going to make for you guys right now. It's sort of like my catch-all at the end. Probably not the best way to organize things, but that's alright. That's just the way I'm doing it, so you're going to have to deal with it. Sorry. Not sorry? Yeah, I'm sorry. Okay. So let's talk about some different things related to evolution and natural selection. And like why populations will change over time, why genes might stop flowing, or why we might lose some characteristics, or why a population might look a certain way and it's different from another population. There's actually a really good video that I'll link to you guys in class um, about these ideas. So first we're going to talk about the bottleneck effect. And you can imagine if you had like a bottle, like not like this, although this is very nice. It's my zillion ounce of water that I definitely need. Hydro homies for life. Drink your water. Anyway, so you can imagine having like a bottle like this, and I put like a bunch of marbles in it, and I'm like, okay, get out as many marbles as you can in 8 seconds. Ready, go. Bam. And you're like, oh my god, what do I do? And you like turn it upside down, and like the marbles are kind of coming out, but it's kind of slow because they can only fit so fast through that little bit. Or, oh my gosh, you might have experienced this. I've experienced this too many times in my life. You're driving down the road in the highway and everything is great, and all of a sudden everything comes to a stop, and you're like, why? Why is this my life? Just let me go to work. It's cold. I hate this. Maybe it's not that last part, but maybe you've been in a long car ride and all of a sudden everything has just stopped. And you're like, what is going on? And then you slowly get up, and you see that maybe was a car pulled over and like 1 or 2 of the lanes are blocked. So all the other cars have had to move over into this smaller space. So now you've got the same amount of cars trying to get through this little space, and it just is very slow. So, but I told you in this bottle example, you got like 8 seconds. Well, that's all the marbles you got out in about 8 seconds. Well, let's take a look and try to think about this in relation to living things and not marbles or cars in a bottle. But first, look at this bottle. We've got white and blue. They're kind of probably in the same amount. Maybe there might even be more white. And we've got some yellow. Well, what we got out of the bottle just happened to be a bunch of blue and 1 white. We lost that yellow entirely. So let's relate this to a real example. A long time ago, there's cheetahs. There's cheetahs today. Wow, okay, so, alright. But there is a lot of different cheetahs. They looked very similar. You'd be like, that's a cheetah, but like they looked different and acted maybe a little bit different. And a disease came and hit their population and killed most of them. Like it literally almost wiped out cheetahs and extincted them. This is like millions of years ago. Okay, so this is a long time ago. Most of the cheetahs now are almost genetically identical. So maybe you had some cheetahs that were like mostly black with like just tan spots on them. That would be kind of cool. Maybe there were some that were larger. Maybe there's some that were smaller. Maybe there's some that were like even faster, maybe more muscular. Or maybe like, do you ever see like a baby cheetah that got rock star hair? Maybe there was some fluffier cheetahs, or maybe like the males had like more of a mane that they kept. We don't know. They died. We're left with the cheetahs we have today, and they're almost all genetically identical. We lost a lot of variety in their population because most of them died out. So the bottleneck effect is talking about when there's a disaster that happens to a population in some way, like maybe there's this population in the forest that they live in burns down. Maybe there is on their side of the mountain where they lived a mudslide. Maybe there was a horrible disease that affected most of them, like with the cheetahs, where it kills a huge amount of the population and we lose a ton of that variety. So now we have a new population that maybe isn't representative or isn't exactly like the old population. That's what we have now. That's what the bottleneck effect is. Kind of going along with that is this idea of genetic drift. It's a random change in allele frequencies. I should change that because we haven't talked about genetics yet. But it's a random change in basically what sorts of traits that you find in a population. And this has a larger effect in a small population. So let's just say, okay, we've got 10 bugs, and something happens, they get smack, and 4 of them get killed. Well, those 4 just happen to be the blue ones. They didn't choose it necessarily, but we have these genetics. They're the genes of the population drift from being evenly distributed, blue and red, to shifting to more red. Okay, that's why it's called genetic drift. The population drifts from, in this case, even to mostly red. You can see that here in these bunnies. Like, okay, so bunnies here had little bunny babies. They mated and had little babies. Okay, well, these guys died. These 5 were able to reproduce. Okay, so when we talk about genetics and genes, you can see they carry the genes for white fur. Okay, so those 5 rabbits were the only ones that could mate, and they had these babies. Only one of them out of them was white, but the white one didn't get to mate again. The only ones that got to mate were the ones that had brown fur. And now they all have brown fur, and there's none of these white ones left. So the types of traits you saw drifted away from having variety to having no variety in this case. So that's genetic drift and the bottleneck effect. You might see those kinds of terms and hear about them, so I wanted to throw that in. Let's talk about something really cool. Let's talk about the evolution of organelles. Oh, this isn't the right one. Girl, this is cool too, but I have to talk to you about that another time. Gosh darn it. That's all right, we'll get to it. I can talk to you about those things too, but I got excited over nothing, talking about special organelles. I'll tell you guys about it. Just not today, I guess. Well, let's think we talked about Darwin. What did people think and talk about before Darwin? Remember, I told you that people knew living things had changed, but really didn't have a good idea of how they changed. Well, there's a scientist, a man named Lamarck, and he said people and animals acquire characteristics over their life and pass it on to their offspring. And his idea is literally called acquired characteristics. So, well, what evidence did he use to say this? So he would say, okay, well, look at the blacksmith. He's like this big, yeah, like me. Oh yeah, check that out. Definitely not fake there. Oh yeah. But he noticed like the blacksmith would be this big burly man. But what did the blacksmith's son look like? Well, eventually he became this big burly man too. So he's like, oh, well, because the blacksmith was working and like lifting the heavy hammers and the anvils and stuff, he gained this muscle, and because of that, he passed it on to his son. That's not true. That's not how it works. So, or he was like, okay, with giraffes, the ancient giraffes had a short neck, but they would stretch and stretch and stretch, and because they stretched, their necks got a little bit longer. And then they passed that long neck on to their child. So he was like so close, but it's just like, nope. So close, but nope, that's not how it works, okay? How did they disprove this? Well, it sounds mean, but some researchers got some mice, and they cut off their tails and had them mate, and all the babies had tails, and then cut off the tails of the babies and have them mate, and all of them would have tails. So even though the parents acquired a tailless little bottom, their babies still had tails because it didn't matter that they acquired them over their lifetime. I'm so disappointed I don't have my like evolution of organelles thing on here. Sad. I will tell you about this though, in my depression right now, about taxis and what is a taxis? Okay, first of all, it looks like taxi and taxis, which is great because a taxis is a movement. And what moves you from place to place if you're in like New York City, like an Uber or a taxi. Okay, so a taxis is a movement towards or away something. If you're moving to something that's positive, you're like, yeah, I want that. So it's positive. If you're moving away from it, you're like, ooh, that's bad. That's a negative taxis. So we can have different types of taxis. You can have phototaxis. That's movement toward or away from light. And some creatures like to move toward or away from light. Like if you've ever been in a place where there's like bugs and stuff, you turn on the light and they all skitter away. Yeah. Let me tell you about how I used to work at Blockbuster. Girl, do I have stories of Blockbuster. But at the first place I worked at, I remember one of my coworkers, I think it was this guy Kevin, there was pizza in the back that someone had brought for us. I think it was our boss, Mary, had bought pizza for us. And he was like, yeah, don't eat that pizza back there. In my mind, I'm like, why? Don't eat this pizza. And I opened the box and out of the box where the pizza was popped these little roaches. Oh man, it was disgusting. One of many classic Blockbuster stories. Like, oh my gosh. People want Blockbuster to come back. Let me tell you, you're going to find someone else to work at one because it's not going to be this girl. Nope, I did my time. So anyway, back to reality. There's chemotaxis, so creatures might move toward or away from like a chemical. It could be food or salt. Those are chemicals. And like I said, positive is moving towards that thing and negative is moving away. What does this have to do with evolution and natural selection? Nothing really. But you know what? In the state of North Carolina, it tells us that learning about taxis and this other thing called kinesis is like this time that this is what I should tell you about. So I'm just going to throw that in there. I mean, we could relate it to stuff, but I think there's a better place to put this. Okay, anyway, tune in next time for more Blockbuster stories. And by more Blockbuster stories, I mean more science. Okay? And maybe I'll actually get to talk to you about specialized organelles. I think maybe that'll be another video. I know it's going to be another video. Oh my gosh, get excited. Why aren't you subscribed to find out when I'm letting out these amazing videos? I mean, come on. What are all those smash that like button, ding that bell, hit the subscribe button to be notified about my exciting videos. This is never going to get old for me. I'm never going to get old of this. I'm never going to get tired of this. Okay. So, anyway, talk to you guys later.